Hey guys, it's Evan Lane with Group 10. Today I'm going to be presenting video 4 about numerical methods used to analyze some problems. So I will be covering ODE45, and you may ask, well, what is ODE45? ODE45 is a built-in Matlab function used to solve ordinary differential equations. Now, when you're coding in Matlab, they have very set formats. And the standard format for ODE45 is TY, ODE45, ODE fun, T-span, why not? Now we'll go over each part of that equation and that format in this presentation, and we're also going to cover some of the ways we've used it during class and how it relates to our case study. So let's go over the format. So like I said, we have ty. Now these are the variables that you're going to be analyzing in your function. ODE45 is the type of ODE we will be using in MATLAB. There are several other types of ODEs in MATLAB with different functions, but for the function we need, we'll be using 45. Now, T-span is the time interval that you will be covering in your analysis. So that usually starts at like time 0 and goes until time final, which is whatever time you set it to end. So you can choose what time it starts if you don't want to analyze the beginning, and you can choose what time it ends if you don't want to necessarily do all the way to the end. So you could set it in a multitude of ways to start at different points. So if you didn't want it to start at time 0, you could start at time 15 and go to time 30. Or if you didn't want it to go all the way to 30, you could say start at 10 and go to 20. So it's a very versatile in the time spans that you can use to analyze these equations. So basically this means like you can do it over the entirety, in the middle, beginning, and end. And why not is your initial conditions. So if you're given a specific initial condition to start at, that's where you'll put that initial condition. And initial conditions can be anything from like, okay, so here's the amount we start at. So this will be where your graph will start. And, that's very helpful for, say, like if there's already pollution, if we're monitoring pollution in water, if there's already pollution in the water, that would be an initial condition if you already have a starting point to start from. So next we're just going to cover like what does ODE45 do? And like I've already said, it evaluates differential equations consisting of points or matrices. So points can be like 0.1, 0.2, or matrices can be a large grid of information or a line of information that involves multiple points. However, to use ODE45 in the differential equation must be non-stiff. ODE45 solves for problems in the format of y prime is equal to fty. So basically what this means is y prime is basically equal to dy over dt. So you have a derivative of dy over the derivative of dt equaling the function involving t and y as variables. So you don't just have, say, y as a variable, and you don't just have t as a variable. You don't know y and you don't know t, and you have these derivatives. And basically what it'll do all the math for you, where it'll like multiply dt to the other side, move y over here, and then solve for those and integrate those equations so that it gives you a set equation and then solves to the points that you give it. And examples of using ODE45 over the semester. So in class, we've done it a lot. We've solved for multiple different scenarios involving environmental topics and systems. And we've chosen the topic of agricultural runoff for our presentation. And we really, so the main issue of agricultural runoff is depletion of oxygen in waterways, which is something we've covered in class. So we have done BOD analysis. So BOD is biological oxygen demand. And we've, looked at the relationship between biological oxygen demand and available oxygen in water. And we used ODE45 to solve for those relationships as well. and we've used it to solve for the equations, and we've also used it to plot points on graphs for these equations. So we've also used it to study the increase in biological oxygen demand, and we've also used it to study depletion, since those are related. So as your biological oxygen demand goes up, your oxygen goes down. And that's just one example of how we've used ODE45 in this semester, and it relates to our case study, obviously, because a lot of nutrients that get into waterways through runoff, agricultural runoff, really impact biological oxygen demand, as well as algal blooms, which absorb oxygen out of the water. So we just picked this as like a really good Matlab topic to cover our case study. Thank you.